Okay, we're going to finish up notes problem number 2. And just like you saw in part 2, when I do the second one without all the extra explanation, it's going to go much quicker than the first time around. So again, I'm going to tell you that we're going to first do part B, but if you're curious how I pick which one I'm doing, I'm picking the one that doesn't have any that are at a slant, because those are easier to do. So I'm going to look at point B, and again, just like last time, I'm going to consider if I'm just seeing this, what can point B feel? Well, point B can feel BX, which we earlier found BX was 580 pounds to the left. So I'm going to draw that in, 580 to the left. It can also feel this force in BC, and again, just like last time, we're going to assume tension, and that goes away from the point. If I get a negative, it means I have compression. So this is BC. And then this point B can also feel this force in this one right here, which happens to be AB. So it can also feel this one in this one, and it's called AB. It's going away from the point, so we assume tension. So now that's all that this point at the corner can feel. So I'm going to do my sum of the forces in the x direction. I have AB and 580 both going negative direction. So they're both going to be negative. Solve the algebra problem. AB equals negative 580. I got a negative here, so it means this one's really in compression. So I'm going to make my little notes at the bottom. AB equals 580 pounds in compression. And I'm going to draw out a result here. My answer, here we go. And 580 AB, that was this one right here. So this one right here is 580 in compression. Okay, now I'm going to do my sum of the moments in the y direction. Well, the only thing on the y is BC. If that's the only thing in the y, it's still equal to 0. So that means that that one actually has 0 force in it. So BC equals 0. I can say tension or compression because it's 0 force. It really doesn't make a difference which one I say. All right, that's it for that one. Now I'm going to do my other point so I can find this missing side here. So I'm going to do it at point C, which is this one up here at the top. So what can this one feel? Well, it can feel CX and CY. So I'm going to put those on. And I know what they are down here. CX is going 280 to the right. Right here. And CY is going 200 up. What else can C feel? Well, C can also feel this force in BC this way. But we just found that BC is equal to 0, so I'm going to draw it in, but it's 0 anyway, so that one's not going to make a difference. And it can feel this slanty one in AC. So again, I'm going to dot this one in because I'm going to break this one up into its two parts, its x part and its y part. So it's got this one going down, which is ACY, and it's got this one going over, which is ACX. That's all the things happening here at point C. If I'm just looking at C, that's all it can tell, those 4 things. So I'm ready to do my sum of the forces. In the x direction, I have ACX is going in the negative direction. And in the positive direction, I have 280 plus 280 equals 0. So ACX equals 280. And in the y direction, I have 200 going in the positive direction, and I have ACY going in the negative direction. So solve that. ACY equals 200. So now I have ACY is 200, and ACX is 280. What do I need to do to find AC? Just Pythagorean theorem, 200 squared plus 280 squared equals AC squared. AC equals 344.1. These were both positive, so this one's positive, which means that it's in tension. So I'm going to write it in my summary here. I'm going to put it on my summary. Let's see if this actually makes sense. I'm going to put on my extra forces that I started with. Oops, 300. And I'm going to put on my reaction forces on here, and we're going to see if this makes sense to you. Because it logically should make sense. Oh, I just did this one the wrong way. If I'm pushing in on this one, does it make sense that this one needs to push out to keep those balanced? That should make sense to you. And if this one's going down, that one has to go up so that these two are balanced. That should make sense. Now, why is this one pulling in? Well, if you consider this one pulling down and this one's going out, if this one doesn't pull back in, this whole thing would tend to tip this way. That's why this one has to pull in to balance those out. Now, how about the tension and compression? Well, if these two are pushing like this, does that make sense? That one's in compression? It should. And here, this one, if this one's pulling down and this one's pulling up and out, should that one be in tension? It hopefully makes sense to you. Let's see if problem 1's answers make sense. So here's the answers we got at the end of problem 1. Let's go through and see if these make sense. If this one is pushing this way at the top, it should make sense that that one has to push that way so those balance. If this one is pushing down, it should make sense that this one has to push up to balance those out. But if that's all I had, it would start spinning this direction. That's why this one also has to push this way to keep it from doing that spin thing. How about the tension and compression? Well, if these are both pushing this way and these are both pushing that way, it should make sense that this one is in compression. And this one, if this is pushing this way, this is a little harder to see, but if this is pushing on this one going that direction and this is pulling down, that puts this one in tension as it pushes like that. That's why this is in tension. Now, if I have a zero member, could I just get rid of it? Why do I need it there if it's doesn't have any force in it? Well, it's just there to make it a rigid shape. If I don't have this one there at all, what would happen to this shape? Well, these two parts would swing in together. Even though there's no force going on here, it wouldn't hold its shape and it would kind of flop around here if there wasn't this panel. That's why we need this one even if it's at zero force. Okay, hopefully those make sense to you. Thanks, that's it for trusses.